This is question number 16. Uh, Question asked is the property which characterizes a solid as a amorphous is. Okay, first option given over here is it is anisotropic nature. Okay, it is not anisotropic. It is isotropic. What is the meaning of anisotropic? Anisotropic means different value of the physical properties in different direction. That is what the anisotropic. But amorphous solids have on an average similar values in different direction. So this is isotropic. So this statement is incorrect. This option is incorrect for this. So definite heat of fusion, it doesn't have a definite heat of fusion. Okay, then second is a short range order in arrangement of the constituent particle. What is the meaning of short range order in the constituent particle? The pattern, we cannot predict the pattern. Like if this is the atom A, then this is B. Let's say this is A, this is B, this is A. Not necessary that this should be B. This may be A, right? So pattern is not over a long range. Okay, it is not repeated over a long range. So that's why it is short range. Like the pattern is not repeated over, like it cannot be like this A, B. We can predict like this is A, then B, this is A, this is B. We can predict, but in the case of amorphous solids, we cannot predict. So we say that it is a short range order. So that's why this is the correct. And sharp melting point, no, they have a range. Like amorphous solid has a range of the melting point. It will be having a melting point, let's say we define like 72 to 73 degrees Celsius. Means this substance will start melting at 70 degree and it will convert completely to the liquid by the time it is 74. Okay, if the range is this way, 70 to 74 or 71 to 73, that way. So it is not having a sharp melting point. So this is also incorrect statement. Question number 17. Okay, this question is based on electrochemistry. Question asked is, okay, cell representation is given, cell potential is also given. No, cell potential we have to find. Okay, so here how will find a cell potential? It is E cell using a Nernst equation. E cell is equal to E naught cell minus 2.303 RT by NF into log of concentration in anode half cell upon concentration in a cathode half cell, right? Or we can write a concentration of the product upon reactant. Means we will have a cell reaction for this. See, advantage of having a knowing the cell reaction is that it helps you to identify what is the stoichiometric coefficients, right? Stoichiometric coefficients means what concentrations you are going to raise, right? Means whatever concentrations are there, it should be raised to some power. You get the idea of that by knowing the standard full cell equation, right? And it also tells you about the n, means number of electron getting transfer. Okay, so that's why cell overall cell reaction is very important. So what we'll do is E naught cell will be very easy to identify from this. We'll write overall cell reaction. So reaction which is taking place at the anode. Anode means it is a oxidation. So what is getting oxidized over here? That is nickel is getting oxidized. Nickel is getting oxidized to nickel 2 plus. So that's why 2 electron. And what happens at the cathode? Cathode reduction takes place of the silver, that is Ag plus gets converted to Ag, right? Ag gets converted to Ag plus gets converted to Ag by accepting 1 electron. So this is a reduction. So over here what we do is we need to make this electrons equal, no? So we'll multiply whole of this equation by 2, right? Now these equations become 2 Ag plus 2 electron and a 2 Ag. So overall equation, in the overall equation we don't show the transfer of electrons, right? So I will add these two equations, let this equation and this equation. So these 2 electrons which are over here, that will get cancelled. What will remain over here is nickel plus 2 Ag plus nickel 2 plus and a 2Ag, right? Concentration, this is about the solids, these are solids, we consider the concentration to be unity. So what will be a EMF of the cell? So we need to know what is E naught also. Okay, we got the value of N, we got the value of N to be is equal to 2 over here. How? It is 2 electrons which are getting transferred, so N is equal to 2 over here. Electrons involved in the reaction is 2, that's why N is equal to 2. What is E naught cell? E naught cell is equal to E naught cathode minus E naught anode. Means it is a reduction potential of the cathode minus reduction potential of the anode. Now which of this is acting as a cathode? How to identify? One way to identify the cathode is it will have higher reduction potential than the other electrode. So here silver is the cathode, and you can see that in a cell representation it is represented on the right side. That is also one way of identifying the whether it is cathode or anode. So this is 0.8 minus 0.25. So this comes to equal to 1.05. Okay, E naught cell, I'll write over here 1.05 minus, they have given a value of this 2.303, this term, they have given the value of this term 2.303 RT by F to be is equal to 0.059. 0.059. N we know, N is what? N is 2. Log will be what? Log of concentration in the anode half cell. What is the anode over here? Silver, right? So sorry, nickel is the anode, like anode half cell, or we can take the help of this equation. So over here it is the concentration of the nickel ion. How much is that? It is 0.08, right? There is no any stoichiometric coefficients over here, right? Plus I would write this to be concentration of Ag plus also, but sorry, not Ag plus, Ag, but it is solid, so we don't consider it. Its concentration is 1. Anything raised to 1 will be what? 1 only, right? So here this is 0.08 of the Ag plus raised to power 2, right? This is what we have done. So further solving this, I'll clean this part, you can take a screenshot of this. So from here you need to solve this 1.05 minus 0.059 upon 2. Now how to solve this, how to get rid of this? Okay, so what will remain over here is one of the 0.08 will remain, right? So it will be log of 1 upon 0.08, right? So you really don't need a logarithm table, I'll tell you this. You can directly solve without a logarithm table. So this will be is equal to 1.05 minus 0.059 upon 2 into log of what I'll do is I'll solve this part over here because I don't have to write that again and again. This could be written as 8 into 10 raised to minus 2. So I'm just solving this. This is 0.08 could be written as 8 into 10 raised to minus 2. So this will be is equal to log of 10 raised to 2 by 8. So this will be is equal to log of 10 raised to 2 minus log of 8. This will be 2 into log 10 minus log of 8 could be written as log of 2 raised to 3, right? Why did I convert this to 2 raised to 3? Because we know the log of 2. Log of 2 is very common. Every student should know this. That is log of 2 is 0.3010 when the base is 10, right? So this is 2 into 1 minus this will become 3 into log 2. 3 into log 2 is 0.3010. So this is 2 minus almost 0.9 and this is 1.1. So this will be 1.05 minus 0.059 divided by 2 and this will be into 1.1. If you solve this further, you will get an answer to be 1.02. Question number 18. The correct order of the conductivity among the following is, the options like the materials Given over here is a copper, pure glass, then glass 0.1 molar, pure water, glass 0.1 molar acetic acid. See, among these, the one which is very good, best for the conductance, copper is a very good conductor of electricity, like copper wire if you consider, then it is a very good conductor of electricity. Then 0.1 molar acetic acid. Now it is a acetic acid. Acetic acid is a weak acid, means it is going to dissociate to very less extent into the water. Yeah, means if it is a, let's say, 100 molecules of CH3 COOH, for simplicity I am considering just 100 molecules. So what will happen if you put this into water? If you put this into water, it will dissociate at CH3 CO minus and a H plus, right? So how many will dissociate? It may be just 5 of this, and only 5 will dissociate to give you this. Remaining 95 will remain as CH3COOH. But still, there is some concentration of H plus and positive ions and the negative ions, right? So there is some conductivity. Then there comes a pure water. Pure water has a very less concentration of the ions. Okay, that is tends to -7, so less. So it will be less conductive than a 0.1 molar acetic acid. And last, the glass. Okay, glass doesn't conduct. So answer is option C. Okay, question number 19. Question. Let's read the question. Consider the following reaction in which ethyl acetate, which is 0.02 mole, is mixed with water 20 mole to form products. Okay, so this is a reaction which is in which this is ethyl acetate, which is there over here. This is what the ethyl acetate is, CH3 COO CH2 CH3. This is ethyl acetate. This is reacted with water in the presence of acid. So this is a reaction. This reaction is about the hydrolysis. Hydrolysis means breaking of bonds using water. So what happens in this case is that in simplest term, OH minus, like in this case, what I will say is that this is the part, mechanism part, if you think. Then this is a OH minus, a negative part will go and attack a electron deficient, a positive part. This carbon is partially positive. Okay, this carbon is partially positive over here because it is connected to electronegative atom. So this will attack over here, and it will, okay, here there is also oxygen, right? Here there is OCH3. Here there is OCH3. This is OCH3, right? So what happens? This pi bond will break first, then this will back bond, and this is the bond which is going to move. So in this case, that's why you are going to get a CH3 CO, new connected is OH, and other is CH3 CH2 OH, that is O minus and the H plus, right? So two things you are getting. One is acetic acid and ethanol over here. Means what is happening? Hydrolysis is happening. Now the thing what they have given is this is 20 mole. This is 20 mole, and this is just how much? 0.02. So to convert all these 0.02 mole, how many will be utilized from 20? It is from 20 mole, just 0.02 will be utilized. So 19.80 or 19.0, yes, 80 is going to remain. Means from this 90 mole after the reaction, how much will be remaining? 19.80. Sorry, not even 80. It is 19 point. How much if you subtract from there? Yes, this much, right? This much of the thing is going to remain 998. I mean, sorry, 19.98 is going to remain over there. Only this much is utilized. So 19.98 is as good as there is no change in concentration of the reactant. Means although this is a one step reaction which shows that rate is equal to K into concentration of CH3 COO C2H5 and a concentration of H2O, your concentration of water is remaining constant even after the reaction, means 19.98, right? 19.98, and it is remaining very very, like it is almost constant. So rate is not dependent on the concentration of this. So rate is dependent only on this. So here this is, although it looks like a second order, but it is a pseudo first order reaction because concentration of water is not changing. So the answer is option B. Question number 20. This is a theory based question. Answer is option B. Just mark this. Okay, here is the next question. Question number 21. Let's read this question. Question says 9.26 gram of ascorbic acid was added to lower the melting point of 200 gram of acetic acid by 1 Kelvin in experiment 1. Okay, in experiment 2, W gram of ascorbic acid was added to raise the boiling point of 200 gram of acetic acid by 1 Kelvin. The value of W in given in gram, okay, that is what is asked. For acetic acid, molar freezing point depression constant Kf is given, and molar boiling point elevation constant, that is also given. So here what we can do is we'll write the formula. This is delta TB, okay, delta TB or delta TF. If you want to write this, then it is what, directly proportional to molarity. We will write this to be Kb, right? Kb into Kb into molality into I factor, right? I factor is called as Vent Hoff factor, and this is Kf molality into Vent Hoff factor. So further, if you write this formula, if I write this formula further, this is delta Tb is Kb. Molality is number of moles of solute upon mass of solvent in kg. So we can write this as a Wb Mb into Wa into 1000. We can write this way. And delta Tf formula could be written as a Kf Wb Mb divided by Wa 1000. And these are the different formulas which we are having. Now how to utilize the data over here? The thing is they have given a freezing point depression constant. Okay, so here there are two experiments are performed where it says is that 9.26 gram of ascorbic acid was added to what, acetic acid. Understand, it is added to the acetic acid. It is added to the acetic acid. 9.26 gram of ascorbic acid. So it lowers the melting point. If melting point is getting lowered, then it is also lowering the freezing point. Means what we can say is that we can use this delta TF. You can use this formula for this. So what would be a delta TF over here? Difference is 1 Kelvin. So difference is 1, which is equal to we'll write the value of this Kf. Kf is 3.77. Weight of the experiment, weight of how much, experiment 1 I am doing. This is 3.77, 26 and molar mass of the ascorbic acid, it comes to 176. Okay, 176, or we'll just write this to be ME, sorry, MB, molar mass, we'll write this to be MB. And weight of the solvent is 200 gram into I factor. Don't forget this I factor. Why? I is a Van't Hoff factor, right? This is the thing. Then second thing what we are having is in second experiment, W gram of ascorbic acid was added to raise the boiling point of 200 gram of acetic acid. Means after adding 2 gram of ascorbic acid to the 200 gram of acetic acid, that is a raise in the boiling point. That is by what? How much? 1, right? So this is boiling point elevation constant. I will be using this formula. So delta TB is 1. This is 2.90, and this is 9 point, how much it is? W gram, right? We don't know this. So W gram is equal to, we'll write this as ascorbic acid molar mass to be this way. This is 200 gram into I. If we equate this, this is also is equal to 1, this is also is equal to 1. So I am equating this. Then if we equate this, then what will happen over here is that let's not spend much time. MB and MB will get cancelled, 200, I and I will get cancelled because it is a ascorbic acid, right? So what remains finally is 3.77 into 9.26 is equal to 2.90 into W. So what is W is equal to weight? 3.77 into 9.26 divided by 2.90. Okay, if we solve this, then I think we should be getting answer to be 12. Let's check. 77 multiplied by 9.26 divided by 2.90. Yes, answer is coming to be 0.12.038, means answer is option this 12.04. Okay, question number 22. Question asked is choose the correct statement among the following options. First is a diamond is thermodynamically a more stable form of carbon than graphite. Remember, although diamond may be a strongest material on the earth, but it is not thermodynamically more stable than the graphite. If you see the structure of the graphite, I'll just paste the image. I'm not getting the proper image over here. So diamond is thermodynamically more stable form of carbon than graphite. This statement is wrong because diamond may be strongest, but graphite has a double bond. Graphite has a structure this way. If we look at the structure, this is what the structure of the graphite will look. Okay, so this is what the structure of the graphite. Okay, these things will be like, this is like it is in one plane. This sheet of cyclic structures will be in one plane. Okay, like this is that one plane. Like these planes will be stacked one above other, right? There is a double bond, carbon-carbon double bond. So therefore graphite is thermodynamically more stable than a diamond. Carbon-carbon single bonds are there in a network structure of the diamond. So answer this is incorrect. Second, option B is reaction rate can be altered by catalyst. This is true, but reaction rate can be altered by catalyst. And second point they are making is but not by temperature. Both catalyst and temperature can alter the rate of reaction. That's why this statement is also incorrect. Means they have said the temperature cannot alter. Option C, for the reaction, if delta G at constant temperature and pressure is negative, then the reaction will be always occur instantaneously. So remember, delta G is negative means it is spontaneous reaction, not instantaneous reaction. So this is also incorrect. And last option is, rate of reaction can be affected by concentration, pressure or temperature. Yes, if you alter the concentration of the reactant, if you alter the concentration, pressure or the temperature, rate of reaction can be altered. So the correct statement is option D. Question 21. Question asked is, the value of rate constant of a reaction is 60 per second. Time required for 20% completion is T1, whereas time required for 60% completion is T2. The ratio of T2 by T1 is asked. Okay. So here we can understand that this is a first order reaction from the unit of rate constant. Unit of the rate constant is per second, means this is a first order reaction, right? So what I'll do is I will use the formula of a first order reaction. They have asked for the ratio of T2 by T1. So what is T2 will be is equal to, let's do it by T2 by T1. So where is time required for the 60% completion? I will write this formula as a time is 2.303 and K is 60, right? Into log of how much? Let's say initial concentration of the reactant is 100. So 60% completion. 60% completion means 60% of the reactant is getting consumed. So what is the concentration of the reactant left? It is 40, right? This is the simplest way to do this. Then what would be a T1? T1 will be this way: 2.303 divided by, again 60 is the rate constant, into log of what, 100 I am considering initial, and time required for 20% completion. 20% completion means how much it is, how much is remaining? 20% is absorbed, right? So 80% is remaining, right? So here the ratio is asked, ratio of T2 by T1. So what I will do is I will cancel this. If you find the ratio of this, I am dividing this, right? This is divisions, I am not writing it again. So this and this will get cancelled, this and this will get cancelled, this and this. So here this 0, this 0, this 0, this 0 is getting cancelled. So this is T2 by T1 will be is equal to what? What is remaining? Log of 10 by 4, and this is log of 10 by 8. So this is very easy question, like it's very in a simplest manner this could be solved. So this is T2 by T1, yes. So T2 by T1 will be is equal to log of this, from the logarithmic identities, numerator could be written as log of 10 minus log of 4, and here this is also could be written as log of 10 minus log of 8. Therefore, just shape this here. Right. So this is T2 by T1. This is log of 10 is 1, and this log of 4 could be written as log of 2 raised to 2, and this could be written as log of 10 is again 1, and this is log of 8 could be written as log of 2 raised to 3. So this will be is equal to 1 minus 2 into log 2, and this is denominator 1 minus 3 log 2. So this is equal to 1 minus 2 into 0.3010, and this is 1 minus 3 into 0.3010. Therefore T2 by T1 is 1 minus 0.6 divided by 1 minus, means I have just multiplied 1 minus 0.9. So this is 1 minus 0.9 is 0.5 0.4, 1 minus 0.6 is 0.4, and 1 minus 0.9 is 0.1. This is equal to 4 by 1, which is equal to 4. So the answer is 4. Question number 24. Which of the following statement about the order and the molecularity of the reaction is correct? Okay, so what is the first statement is the order of the reaction can be a fraction and molecularity can be 0. See, order can be fraction. This is true. We can have a order like half order, 0.5 order. It could be a fraction. Molecularity can be 0. Molecularity means what? By definition, molecularity is a number of molecules which collide simultaneously to bring about a chemical reaction. That is what the molecularity. Like molecularity minimum value is 1. Okay, so there may be a 1 molecule, 2 molecule colliding, right? So it cannot be 0. That's why this is incorrect. The order of the reaction can be 0 and molecularity can be fraction. Yes, order of reaction can be 0. We have a 0 order reaction, but molecularity can be fraction. See, molecularity is fraction means what? It is 0.5 or 1.5, 0.7, 1.2. See, molecule means it is how many molecules completely colliding. One full molecule colliding with another full molecule. So if they collide at one common point, and we call that to be molecularity to be 2. Same way, if three complete molecules are colliding at one common point, we will say that molecularity is 3. So what they are saying is molecularity can be fraction. So molecularity cannot be a fraction. It could be 0, 1, sorry, it could be a 1, 2 or 3. So for that reasons, this is also incorrect, right? Molecularity is applicable only for the elementary reaction. Molecularity is applicable only for the elementary reaction. Yes, this is true. See, molecularity is applicable only for the elementary reaction. Like for the complex reaction, molecularity has no meaning. You know, for a complex reaction, molecularity is defined for the individual steps. Okay, but we don't add the molecularity of the individual step. Okay, there also molecularity is applicable to elementary reaction only, right? So for this reason, option C is correct. And last, option D, why it is wrong? Let's see. Molecularity of the fastest step in a complex reaction is equal to the order of the overall reaction. No, this is also not correct. See, order of the reaction is taken to be equal to the sum of stoichiometric coefficient of the slowest step. But molecularity is not like that. Molecularity is defined independently for all the steps, and we don't add the molecularity of the independent steps, okay, in a complex reaction. So option D is incorrect. Answer for question number 25 is option D, theory based question. Question number 26. The most among the group 15 hydrides, the hydride which has the lowest boiling point. Remember, the boiling point, one of the factor on which boiling point is dependent is boiling point is directly proportional to molar mass. More is the molar mass, more is the boiling point. But one more factor which controls the boiling point is the hydrogen bonding, intermolecular forces. But if we go to see, then bismuth hydride, the topmost hydride is of the family group 15 is NH3, right? Then phosphorus, pH3, then arsenic hydride, antimony and antimony hydride, and last is bismuth hydride. Among this, maximum molar mass is of the bismuth hydride, right? So according to that concept, boiling point should be highest for the bismuth hydride, right? But they have asked a lowest boiling point, then according to that, lowest boiling point should be for the ammonium hydride. But ammonium hydride is not having the lowest boiling point. It is a pH3 which will have lowest boiling point because of its lower mass. Why not ammonia? Ammonia, since in ammonia nitrogen is electronegative element. Nitrogen is electronegative element. So what happens is there is a hydrogen bonding between the molecules. So this ammonia has a hydrogen bonding between the molecule. Hydrogen bonding is the strongest intermolecular force of attraction. Hydrogen bonding between this molecule. Hydrogen bonding. So this will not have the list, although its molar mass is less in a whole group. So here it is pH 3. So the answer is option C. Okay, this question, the order of the increasing bond dissociation enthalpy of the fluorine, chlorine, bromine, iodine. Here orders are given. See, this question is based on a bond dissociation enthalpy. Remember that bond dissociation enthalpy means bond breaking enthalpy is directly proportional to bond strength. More is the bond strength, more is the bond dissociation enthalpy. And bond strength is directly proportional to bond length, right? Bond length. If we go by that, if you want to represent a topmost molecule, that is F2, then F2, fluorine, then chlorine or bromine or I2 molecule, then I will write the size of the fluorine molecule F2. This is, let's say this is a fluorine and this is a fluorine, and this is a bond length, right? Then chlorine, I will write this is a chlorine and this is a chlorine atom. As we go down the group, size increases now of the atom. So this is the bond length. Then bromine will be this way, just writing the like bigger size. So this will be a bigger bond length. And iodine, if I want to write, then I will write it still bigger, right? This is what the iodine. If we go by this trend, if we go by this this concept, then the order should be what? The least ionization, least the most bond dissociation enthalpy will be of the fluorine, because 1 minute, bond strength is directly proportional to bond length. Sorry, I made a mistake over here. Just make a correction. Bond strength is inversely proportional to the bond length. Okay, bond length. Okay, so here smallest is the bond length, strongest is the bond strength, right? This is of the F2, this is of the chlorine, this is of the bromine, this is of the iodine. That should be the thing. But the thing, one more factor is over here, is that the inter-electronic repulsion, right? So here fluorine is not having the highest bond length, because fluorine is very small atoms. They are very small atom. There are 3 lone pair on each fluorine. So there is a lot of repulsion, inter-electronic repulsion. So this bond is not very strong, although it is smallest, right? So the correct order will be over here is like chlorine will have higher strength, chlorine, then bromine, and instead of iodine it is a fluorine. This is an exception which you will have to remember, and the least bond strength will be of the iodine. So the answer is option B. So the answer is option B. Okay, here is the question which is asked, question number 28. Let's solve this. I would like to solve this because this question has a lot of concept. Okay, so we'll do this. I'll just I have just made this frame, so that it just saves our time. So let's learn this. So first we'll understand what is a hybridization. Like hybridization, this is 4s orbital, sorry, 3d orbital. This is 4s, 4p, and 4d. Like this is third shell and this is the fourth shell, right? 4s, 4p. So electrons, like when I talk about the nickel electron, nickel will be what? Independently, when it is nickel, its electronic configuration will be scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel. It is 4s2 3d8. Means here there are 2 electrons, here there are 2 electrons, and here there are 8 electrons. 1, 2, 3, 4, 5, 6, 7 and 8, right? So carbonyl, if you talk about a carbonyl, then carbonyl is a neutral, right? So what is the oxidation state of a nickel over here? Nickel is not having any oxidation state. Nickel is in zero oxidation state because carbonyl is a neutral, no? So I will write nickel as it is, because this column I made for writing the electrons in a, you know, in oxidation state. Oxidation state was there, then I would have some removed some electrons, but nickel is in this. So now nickel in, now next call here, what I am doing is nickel in nickel carbon, nickel in a tetracarbonyl. Now what is a carbonyl? Is it a strong field ligand or a weak field ligand? Like if there is a strong field ligand, then what will happen is that pairing of the electron takes place, right? And if it is a weak field ligand, then pairing doesn't take place over here. If we refer to the spectrochemical series, then what will happen is carbonyl, right? Carbonyl is a strong field ligand. Strong field ligand means it will show a pairing, like there are 8 electrons, no? So 1, 2, 3, 4, 5, 6, 7 and 8, and these 2 electrons which were there in the s orbital, they will come over here. So now how many ligands are there? There are 4 ligands. 4 ligands means I will write the ligands in a different color. Okay, I will use this green color for the electrons of the ligand. So these are the ligand 1, 2, 3 and 4. So this hybridization is what? 1 of s orbital and 3 of p orbital, right? So this hybridization is sp3, means nickel is sp3 here, means p is 4. Okay, let's clean this. We'll do it for a platinum chloride. What happens is, when you have 4 ligand connected, it is either sp3 or dsp2. This is the hybridization. Now coming to this platinum, right? Platinum electronic configuration, like platinum belongs to which group? It is not like scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Platinum is not there, right? So we have to know the electronic configuration of the platinum. It is 6s to 5d9. Electronic configuration of the platinum is 6s to 5d9, right? This is what the electronic configuration of this. So here this will be, I will write the electrons of this. This is 5d, this is 5d orbital, this is 6s, 6p and 6. 1 minute. I should have shown this to be like this should be d orbital. D orbital means just 5. Just cancel it. These boxes won't be there. These things won't be there. Just so total 5 will be there. Okay. So we can just white out this way. Means these are the orientations of the d orbital. So 6, 5d, there are 9 electrons over here. There are 9 electrons in the case of platinum. 1, 2, 3, 4, 5, 6, 7, 8 and 9. And here there are 2 electrons. This platinum. So what is the oxidation state of the platinum? Oxidation state of the platinum here will be +2, right? Means you will be putting this x plus 4 into -1 is equal to -2. So x will be is equal to +2. So platinum in +2 means what? Platinum in +2 means 2 electrons will be removed. So these outermost will be removed. So here 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So now platinum is linking with halide, right? So halide is what kind of ligand? Is it a strong field or a weak field? Halide is a weak field ligand, right? So platinum in platinum Cl4 and 2 minus, right? Here it is weak field ligand, so pairing is not going to take place. 1, 2, 3, 4, 5, 6, 7, 8, 9. Pairing is not going to take place directly. There are 4 ligands, right? There are 4 ligands, and what they are saying is that 1 minute. Chlorine is weak field ligand, so pairing is not going to take place, and 4s1 3d9. Okay, in platinum 2 plus, these 2 electrons will be removed. There is no pairing taking place. Yes, there is no pairing taking place, so this will be what? Okay, here the mistake which I made is this is 1. Okay, 6s 1 it is. So here there is just 1 electron. Okay, just 1 electron is there. So it is in +2 oxidation state. So this 1 electron is removed, and uh, 1 more electron is removed from there. 2 electrons are removed. So this electron will be removed, and what happens is here the ligand is going to come, the electronic configuration of the ligand. Ligand will be coming from here. 1, 4 ligands are there, which is weak field ligand. So hybridization is DsP2. Hybridization is DsP2. Right? Means over here this is directly given. DsP2. COF6. COF6 means either sp3d2 or d2sp3. Okay, so I'll clean this part. So COF6. So cobalt's electronic configuration. Cobalt's, that is scandium, titanium, vanadium, chromium, manganese, iron, cobalt. 4s2 3d 4s2 3d7, right? So this is the configuration. So here there will be how many electrons? There will be in d orbital, this is 3d, no, this is 4s, 4p and 4d. So here there are 7, 1, 2, 3, 4, 5, 6 and 7, right? 4s2, and here there are 2 electron. Cobalt's oxidation state over here is +3. So cobalt over here is in +3 oxidation state. So we are going to remove one total 3 electron, 2 from here and 1 from here, right? The cobalt is linked to a fluorine. Now fluorine is a weak field ligand or a strong field ligand. Fluorine is a weak field ligand, right? So weak field ligand means a pairing is not going to take place. Means I am writing this for cobalt in COF6 3 minus. Pairing is not going to take place over here. So ligands, there are 6 ligands, right? There are 6 ligands, and ligands will be placed here. There is no empty space. No? So here 1, 2, 3, 4, 5 and 6. This hybridization is what? sp3d2, right? There is one of the s orbital, 3p orbital, and 2 of the d orbital. So answer is sp3d2, no? So answer is sp3d2. So R is 1. And last will be oxalate is this. This is the only option, no? So the answer is option D over here. Here answer is for question number 29, theory based question. Answer is this, B. Question number 30, the thermal stability is less and reducing character is high for what? So thermal stability will be about a bond strength, which is having the lowest bond strength over here. The one which is having the highest bond length, that will have the lowest bond strength, right? So thermal stability is means it is about a bond strength. Less bond strength will be for, like, oxygen is there. There is a oxygen, sulfur, selenium and tellurium. Tellurium is the biggest atom, no? So tellurium, if this is the size of the oxygen, this is the size of the sulfur, this is the size of selenium, and this is the size of the tellurium. This is the hydrogen atom connected to this. This is the hydrogen atom connected to this. So, and this is the bond length, I will say. So this is the bond length. So one which is having the higher bond length, right, that will have the least thermal stability. So less is thermal stability is tellurium hydride. So answer is option D.